Hello and welcome to this quick video about something that happened to ExpressLRS at the end of July. I'm making this specifically for a patron of mine called Chris who asked the question, but I'm sure if Chris is asking, lots of other people will be unaware of this, or if you are, that would be useful to show it. And that's the fact that as of ExpressLRS version 3.3, they have finally added in the support for SBUS. Now, traditionally, there's only really two outputs been available with ExpressLRS. CRSF, which was the default protocol that it was originally created with, engineered based on the TBS CRSF protocol. Fantastically useful, uses 4 wires, a ground, plus 5 volts, a transmit and receive pin, allows you to get the radio control information into a flight controller, but also crucially get your telemetry back. And we've also had lots of different PWM receivers kicking about as well. Lots of people have made those, and they're great for those people who want to control things like cars, boats and planes directly without the need for a flight controller. However, many people, myself included, have been asking the developers, please, please, please add SBUS support back in. And they've been incredibly reluctant to do so because in their opinion, SBUS was a legacy protocol and was only used on legacy systems. Apologies for the air quotes. But there are lots of reasons why SBUS is still an important protocol and still used widely in the hobby, and I'm very excited to say that as of version 3.3 of ExpressLRS, it has been added back. Now, in case you missed it, you can actually look at all this stuff in the release notes. This is ExpressLRS version 3.3, so if you're running this or later, then you should have access to this stuff. And there's loads and loads of improvements going on. But if we go down here, you can see here that one of the big deals is that SBUS is added, and quite jokingly on the website, and I quite like the humour here, after all the bitching and whining from us in the past, ELRS finally added SBUS, and about time too. Now what this means is that you can tell your receiver to talk SBUS, and that's whether or not it's one of the traditional little receivers that only has those 4 pads and 4 wires on. You can basically say don't output CRSF, use SBUS, but also crucially you can configure one of the PWM receivers to also output SBUS too. And why would that be useful? Well, say for example that you want an SBUS connection to the flight controller for the main flight controls, but you want to output a PWM on one of the spare pins, maybe for a pan and tilt setup, for something like a head tracker, or maybe to operate gear, or things that your flight controller can't control. You can still control them directly from the radio, and it gives you an awful lot of flexibility. So I have just finished flashing a couple of receivers here and playing with this stuff, and I thought it would be interesting to show you what it looks like. So what I've done is I've updated this ExpressLRS receiver to version 3.3 and configured it. So as you can see here, SBUS is working beautifully. So let me show you how I've done that. Again, this is version 3.3, so if you haven't updated it already, you'll need to do that. So here on the computer, what I'll be able to do, because this ExpressLRS receiver has been sat for 60 seconds, it's created a Wi-Fi access point, so we'll connect to that, and then we can have a look at all the settings and what has changed. And again, this is one of the Radio Master ER6GV 2.4 gig diversities, but the beta FPV stuff works exactly the same. This shouldn't be unique to any one manufacturer. Now here's the standard 4 things you have, your options, Wi-Fi and your update. We're going to go into the model tab though for the things that we need. And normally what you have on any kind of setup is you have the ability to select the kind of mode, i.e. how quickly it's updating, useful for analog or digital servos, and then you can decide which channel you want output in which place. And you can also do things like set what the failsafe is going to be for the PWM outputs. Now what I did here, and I went through each of these in turn, looking for what the options were. And here you can see it goes from 50 to 400 Hertz, 10K Hertz duty, on and off. But excitingly, on PWM2, it has the option to set serial TX. And when I selected that, it set output 2 as serial transmit and output 3 as serial receive. However, at the moment, serial receive is grayed, because when you select serial on something like this, it's going to identify 2 pins and set one as transmit, one as receive. The really funky stuff is down here. You can select now the serial protocol that you want to be put out on those serial TX pins. Now, not all pins, again, are available to be selected to output the serial stuff. That's dependent on the receiver that you've got, but you can just go through each of them until you find the ones that are. Once you've got that set, if we click down here, we can actually see that we can output CRSF as normal, inverted CRSF, we can output SBUS, inverted SBUS, SUMD, or DGI RS Pro. And obviously we've just selected SBUS and then said save. And then by plugging a lead into the serial TX output, channel 2, that is where the SBUS signal is going to appear, and it all works. So there you have it. It's not particularly difficult. All you have to do is make sure your receivers are updated to ExpressLRS 3.3. Don't forget the module in your radio is going to have to be on a version of 3. Whatever to be able to talk to that. But once it's on 3.3 on the receiver, you can just go in and you can configure it on the radio or via the Wi-Fi settings to output SBUS. Again, just be aware that for PWM systems, it'll be specific pins that seem to be identified as the ones capable of outputting a serial receiver. So you might have to hunt around to find which ones those are. But once you've found it, select serial receiver, then you can just scroll down, select SBUS, reboot everything, and then your CRSF system will be able to talk to those older flight controllers and older flight controller systems and stabilizers that need an SBUS protocol. Thank you for watching the video. If you watch my videos and find them useful, then please take a moment to hit the like and subscribe button. It helps the channel a lot. If you really like what I'm doing here, you can become a Patreon and support the time I spend helping others and get access to lots of exclusive benefits. Link is in the video description. Remember that all the videos on the channel are organized into playlists, so you can easily use those playlists to find all the videos on a subject that you are interested in. Add Painless 360 to your searches on Google and YouTube, and it'll help you find my content for any particular topic. Thanks again for watching, and as always, happy flying.